Hey there everyone, it's Calculus by Christee, and here is my best take at FRQ number 1 from the 2023 AP Calculus AB exam. And the rubric hasn't come out yet, so this is just my best guess at the problems, but when that rubric does come out, I will link it below, so take a look at that. All right, here is question number 1, part A. So it talks about this customer at a gas station, and then it asks us to, using correct units, interpret the meaning of this integral. And so the meaning of that integral is that when you take the integral of a rate, you find an amount. So if we're taking the integral in gallons per second, we get out gallons. So this integral represents the number of gallons of gasoline pumped into a gas tank from 60 seconds to 135 seconds. Then it asks us to use a right Riemann sum with these 3 subintervals to approximate this integral. And so using a right Riemann sum, if I am looking from between 60 and 90, I am going to use the height on the right side. So between 60 and 90, that's a base of 30 with a height of 0.15 because I'm using the height on the right side. Then if I go between 90 and 120, that's a base of 30. And then again, I'm going to use the height on the right side of that interval, which is 0.1. And then the last one goes from 120 to 135. So there's a base of 15 with a height of 0.05, since that's the height on the right. That gives us a value of 8.25 gallons for part A. For part B of question number 1, it says, must there exist a value C between 60 and 120 such that f prime of C equals 0? As soon as I see them ask us about the derivative of the function we're given, I know that means we need to use mean value theorem. And if you'd like to see a video that I've recorded in the past on mean value theorem, click here to see that video. So as soon as I know I'm going to use mean value theorem, I first have to ask myself, can I even use mean value theorem? In order to use the mean value theorem, the function must be both differentiable and continuous. So this is when I clicked back to part A and I saw, yes, there is a differentiable function f. So I do know that, great. F is differentiable, and if a function is differentiable, that automatically means f is also continuous. So since I know I now can use the mean value theorem, I'm going to find the average rate of change. So I'm going to find f of 120 minus f of 60 over 120 minus 60. Using the values from the table, I can see that I get an average rate of change of 0. And therefore, the mean value theorem, or Rolle's theorem, and you can use Rolle's theorem if your average rate of change is 0. And actually, to also watch a video that I've made on Rolle's theorem in the past, click here to see that video. So therefore, there must exist a value C, because of the mean value theorem, or Rolle's theorem in this case, where C is between 60 and 120 such that the instantaneous rate of change equals the average rate of change, which is, in this case, 0. So, a great mean value theorem problem right there. Let's move on to part C. Part C gives us this new function g of t, and it says, using this model, find the average rate of flow of gasoline from 0 to 150. Here's your standard average value problem. Average value is 1 divided by b minus a, in our case, 150 minus 0, times the integral from a to b of our function. And what I did is I used my calculator for this one because problem number 1 on the AP exam, the first FRQ, you can use a calculator. Here's some advice. As soon as I get to a function on the calculator portion of the AP exam, I'm plugging that into my y1. Let me show you what I mean by that. So I come over here and y equals, I go to y1 and I type in the function they give us, because most likely you're going to have to use it several times. Once I have that in there, I can go to my main screen and I can say, okay, I'm finding the value of 1 over 150 minus 0, or 1 over 150, 0 to 150 of y1. And I can get that y1 by pressing second trace. Second trace pulls up that y1. And you can see here that I get this value as my answer. And so that is where this is coming from. Now I know in the AP exam you need to provide at least 3 decimal places. I gave more here, that's fine. And the unit here for the average value would be gallons per second. Part D says, using the model G defined in Part C, so I went ahead and kind of copied that over here, find the value of G prime of 140. Once again, I use my calculator for this exclusively. To find the derivative, I would be using Math 8 on the calculator. Those were the buttons I would press. Once again, because I stored this as my Y1, I could do Math 8, select Y1, and then evaluate the derivative at the value of 140. I get this value here. Again, I went one more decimal place beyond 3. You have to have at least 3 decimal places. And then it also said interpret the meaning of your answer in context of the problem. The meaning of this is at t equals 140 seconds, so you have to state what specific moment in time. The rate of flow of gasoline, that was G of t, is decreasing because I got a negative value, decreasing at a rate of 0.0049 because you want to use the positive value. Negative, you said decreasing. I'm going to say decreasing at a rate of 0.0049 gallons per second. And that is question number 1 from the 2023 AP Calculus AB exam. I hope you found that useful. If you did, give it a thumbs up and go ahead and subscribe to my channel. I'll be coming out with the other 5 questions of the 2023 AP Calculus AB exam, so look out for those coming soon. Thank you so much for watching. See you in the next video.